Hello friends! Today we'll explore how to write classes that are easier to use and understand, imagining a car as our frame of reference. Let's create two nodes in our scene, a driver and a car as a child of the driver. Then attach a new script to each of the same name. Cars are very complex pieces of machinery, and most people who drive them have no idea how they actually work. They only understand how to operate their car. Let's start in the car script and give it a class name of car, then add a variable for the year of the car as an integer, another for the make of the car as a string, and another for the model, also as a string. Exporting all of these, I'll set my car to be a 2007 Honda Civic. When creating a new class, be sure to save the script before trying to use it. In the driver script, the driver will need a reference to the car, which we can store in a variable of type car. Nodes can access other nodes in the scene tree, most often their children, using another tag similar to export called onReady. Using the tag onReady, we can assign the variable a value after the node is ready, which means all of its children are also ready, but before calling the ready function of this node. We can assign it the return value of a built-in function, getNode, which accepts a node path as a parameter. If we specify the name of the child node in quotation marks, we now have a reference to the child node stored in a variable, and we can access its properties and functions, including those in the attached script. Overriding the definition of the ready function, we can access the car node and print out its year, make, and model. The ready function is executed after the onReady tags. A shortcut exists for the getNode function to make this easier, the $, followed by the same node path. Let's switch back to the car script and add another variable. This one specifying whether or not the engine is running as a boolean. As a driver, we know if the engine is running, and we have control over whether or not the engine is running, since we can choose to start or stop the engine using the key. So we would consider this variable to be public. Another property of our car might be the number of cylinders in the engine, as an integer, and I'll assign it to have a value of 4. This is something that the driver doesn't need to know, can't access easily, and should never be allowed to change. So unlike the public variable, this one would be considered private, and we can mark it as private by preceding its name with an underscore. In the driver script, we can set the value of engine is on to true by putting the key in the ignition and turning it. But first, we should be pressing the brake pedal. Let's use a function to set pressure being applied to the brake pedal, which we will assume is up to a maximum of 20 kilograms of force. So to start our car, we should probably set the brake pressure to somewhere around 10 kilograms. Back in the car script, we will need to define this function which sets the brake pressure. Like the engine is on variable, this would be called a public function, since it is being used by another script. This function will accept a floating point number as the parameter representing the amount of pressure being applied to the pedal. But what does the car actually do when we apply pressure to the brake pedal? From the perspective of the driver chooses to apply a certain amount of pressure to the pedal without ever knowing the exact position. From the perspective of the car, the position of the pedal is what is being measured and used to stop the car. The car uses the position of the brake pedal to adjust the amount of pressure being applied to calipers which hold brake pads against the wheels of the car, not to mention the complexity of anti-lock brakes or other systems. So if we were actually programming a real car, we would need to write several complex functions here that convert the simple action of the driver applying pressure to the brake pedal to the complex mechanics of squeezing the calipers. This is part of the internal functions of the car, and not anything that is controlled or accessible to the driver through any means other than applying pressure to the brake pedal. So we would consider these to be private functions, since they are only meant to be used by the car itself, and we can mark our private functions by preceding their names with an underscore. Notice how this is the same as the process and ready functions. The way GDScript uses private variables and functions is more like the way other languages use protected ones, in that they are accessible to inheritors. GDScript does not actually enforce these privacy rules, however, and scripts can still access private members. These conventions exist purely to facilitate better class structure and design. Another way of using comments in GDScript is to create regions of our scripts that are related, using the region keyword, followed by the name of the region. We can end a region using the keyword endRegion. So let's make a public region and a private region in our car script, separating what should be accessible to the driver and what should not. To keep things simple, let's say that the driver only needs to be able to turn the engine on or off, apply pressure to the throttle, apply pressure to the brake pedal, or turn the steering wheel. What actually happens inside any of these public functions is the internal mechanics of the car itself. The driver does not need to know how any of it works to operate the car. For example, when pressing the throttle, what is actually happening is that the car opens an air intake valve on the engine, letting more air and oxygen into the engine. So the car needs to use a sensor to measure the amount of airflow and the amount of oxygen that is now flowing into the engine, then use that to adjust the amount of fuel being injected into the engine's cylinders. All of these functions are private, since we do not need to know what they actually do in order to drive the car. The way our car moves would be in the process function, and we'll need another private variable named phase to represent which of the 4 phases each cylinder is currently in. In the car's process function, if the engine is running, we can iterate through each of the cylinders of the engine, adding together the cylinder and the phase, then modulus 4, we get a different phase for each cylinder. Matching this number, we can tell each cylinder to perform a different phase: the intake stroke, compression stroke, combustion stroke, or exhaust stroke, each accepting the cylinder as an argument. Then increase phase and cycle back to 0 when it reaches 4. Each of these functions can then control the intake valves, exhaust valves, fuel injectors, and spark plugs of each cylinder to run the engine. The amount of force being produced by the combustion strokes of each cylinder would then move the car forward, while the brake pads try to stop the car, and the steering wheel position changes its direction. The car's position would then be moved by the direction, speed, and delta time. Don't worry if none of this makes sense to you, because that is precisely the point of this lesson. You do not need to understand it. Since all of this is in the private region of the script, the driver does not need to know how any of this works in order to drive the car. They only need to know how to use the public region of the script. The separation of public and private enforces 2 important principles of object-oriented programming. Encapsulation is the public region, providing access to public variables or functions that are easy to use and simple to understand. And abstraction is the private region, hiding the details of complex systems or mechanics which do not need to be understood to be used effectively. You will know if your classes adhere to these principles if you can hide all of the private contents and still easily understand how it is meant to be used. So our driver can now simulate driving the car by accessing only the public regions of the car script, from pressing the brake and starting the engine, to releasing the brake, pressing the throttle, turning the steering wheel, etc. These principles are not only important for our own scripts, but also allow us to use scripts written by other developers without fully understanding how they work internally. They also make our scripts more flexible. Imagine if we swapped out our gas car with an electric car. Would anything in the driver's script need to change? Only the car script would need to be changed for an electric car script, since all of the public variables and functions would still exist in the electric car's script. Likewise, we could also change the driver script to an autopilot script, one which only needs to be given a destination and will automatically be able to operate the car. In the next lesson, we'll learn even more about object-oriented design principles. I'll see you in the next lesson.